Welcome back, guys. This is Ashwin here. In this video, we are going to solve the problem maximizing XOR. Given two integers L and R, find the maximum value of A XOR B. Written A, this plus and circle symbol. So this is the XOR symbol. So in Python, we'll be representing by exponential symbol. So make sure you use the corresponding symbol for your language. I think it will be same for all the languages. So where A and B satisfy the following condition. So it's in the range L less than or equal to A, less than or equal to B, less than or equal to R. So A and B, it should be between L and R, that is the range. So for example, here L is 11 and R is 12 means these are the possible cases. So if both numbers are same means it will be 0. If both numbers are different means it will give us some new number. So we have to maximize this number. So that is the objective. So here our maximum value is 7. And let's see the constraints. So constraints can go up to 10 to the power of 3. As the constraint is so small, we can also use the brute force approach to solve this problem. I am going to show you two different solutions for this problem. One is brute force and one is optimal approach. So for optimal approach, it will be somewhat difficult than the other problems because we are dealing with bit manipulations. So you have to try out with some examples. You have to write it in some pen and paper and come up with your own logic. So that's how you can able to find an optimal solution for bit manipulation. Now here we have two inputs. This is L and this is R. And out of these all possible cases, 7 is the highest number that we are getting using the XOR operation. And again in the sample input 1, we have 11 and 100, and the maximum we are getting is 127. So as you can able to see, you can observe some pattern here. All the bits are 1. So 7 will be having 3 set bits. So for 127 we'll be having 6 set bits. So all the bits will be 1 for this number and for the number 7 also. So this is the pattern we are getting. I will be explaining the logic later for the optimal one. Let's solve it using the brute force approach first. Now we are going to initialize some value that will be max XOR equals 0. Now for I in range of L comma R plus 1, because the range is inclusive less than or equal to R, that's why I am using R plus 1 here, because for loop is exclusive. For j in range of L comma R plus 1, so this is the brute force approach. I am going to say max XOR equals max of max XOR. So it will just store the maximum number in the max XOR. That is the logic of this line. So I'll be having I XOR j. So if this number is bigger means it will be storing this number to the variable. That's how this brute force works. So it will try for all the combinations. Let's return max XOR. Now let's run this. Now we have solved the sample test cases, and if you submit it, it will also work. Now this is the brute force approach. So it's just order of n square time complexity. So I'll comment this out. For brute force, I'll just mention it. Brute force. Now we are going to see about optimal approach. Now for the optimal approach, what I'm going to do is I will initialize some variable. Let's say n equals L XOR R. So we will be getting a XOR of both these values. So here in this pattern, as you can able to see, we are having 7, that is 2 to the power of 3 minus 1, and here 2 to the power of 7 minus 1. So that's how we are getting these numbers. So similarly, we are going to do it. I will initialize result equals 1. Now while n until n becomes 0, this loop will continue. So what I'm going to do is I'm going to exponentiate this result. So left shift equals 1. So this will exponentiate, and for the n we have to divide it by 2. So for that we'll be using n right shift by 1. So this is actually dividing it by 2, and this is actually exponentiating by 2. Now after the loop breaks, we'll be displaying the result, but it's in the power of 2. So but here we are having 2 power some number minus 1. So we'll be returning result minus 1. So to understand the logic, I'll also print the variables in the loop. So print n equals n. I'll be printing it outside once, and here after doing the operation we will print it. Initially our result is 1, that we know. So we will print n, we will print result. So result. Now let's run the code once. So we have run the code. This is for both the input. So we will go with 10 and 15. The output is 7 and we got the output 7. Initially n is 5. In the loop we are dividing the n by 2 and increasing the result in the power of 2. So this will be 2, 2, and after that it's dividing it by 1, and after that it's dividing by 2 again, so it will be 1 and the result is 4, and finally n equals 0, result is 8. So we will be getting 8 minus 1, 7. That is the answer for us. So similarly for this also 11 and 100 we are going to XOR. After doing the XOR operation, the result is 111. So we'll be dividing the n by 2 and incrementing the result by 2 powers. So as you can able to see, until it reaches 0, it's actually incrementing in powers of 2. So the final result is 128, and when we do 128 minus 1, that is 127. That is our result. So how can you come up with this logic? So for this is you have to actually observe a pattern. So I observe the pattern is it's going in powers of 2. So that's the pattern I have observed while seeing the result. So how to arrive at this result? So for that I have used OR operation initially instead of XOR. So I have tried it manually using pen and paper, using for this test case and some normal test case also I have done it. And after that only I can able to come up with this logic. So it's like a trial and error, because we can't like initially know we have to use this XOR operation first, and we have to do this logic. So this logic I'm clear, and this logic is also I'm not much clear. I just use some set bits and done something before, and in the end only I can able to get it until the last set bit it's actually moving. So that's how I can able to arrive this logic. You can also get the logic simply. So let's say L and R. So I'll be displaying it for one test case. So 5, that is showed here. What I'm going to do, represent in bitwise manner. So 5 is 1, 0, 1. So this is the binary number of 5. As you can able to see, this is the last set bit, and we are going to set all the bits to 1. That's how we are getting 7. So this is also some kind of another logic. And again for 111, I think here for 111 we have to get the binary number 111. So we'll be having around 6 bits. Let's see what is the binary number for that. I'll be printing binary of 111. Run the code. It'll be easy to copy and paste it. So this is the binary number. Now, so here also you just set all the bits to 1 and we'll be getting 127. That's how we are getting this. That's how we are getting the result. You can also do like this, like converting into string and getting this result. So there are multiple ways instead of this brute force approach. That's the tricky part in bit manipulation. You just have to convert into bits and observe some pattern. That's how all the problem works. So I think we will remove all these things. We have no some. I think you including this will be having 3 logic for this problem. So let's run the code once. I think we have to remove this also. This is the complete code. Now let's submit the code. And we have solved the problem. So I guess we have seen 3 different approaches for this problem. Like this, you can able to use it for many other different problems. Even they didn't mention bit manipulation means you can use some kind of approach like this. Generally, we have to find a pattern from the existing example inputs and try to come up with the logic. That's the simple process we have to do. And that's it, guys. Stay tuned for the next video.